So first of all, for numbers 1 through 4, it's asking us to find the distance between each pair of points. Okay, so let's go ahead and remind ourselves our distance formula. Okay, we want that definitely to be on our notes. Okay, so I'm going to write the distance equals the square root of, give yourself some space under there, just like on our starter, x2 minus x1 squared plus y2 minus y1 squared. Okay, and remember those x2s, x1s, it literally just means your first x, your second x. It's not like being squared or something like that. Okay, so let's go ahead and find the distance between these guys. So for number 1, does it tell us what our coordinate points are right off the bat?
Sure.
No, it does not. We need to find them, right? That would be nice if it told us what they are, but we got to find out what they are. Okay, so somebody identify one or both of these coordinate points for number 1. Okay? 0, 3, which we're going to switch around because 3 is my x, 0 is my y. 3, 0.
Negative. Oh no, positive 4, negative 5.
You got it. 4 for my x, negative 5 for my y. Beautiful. Okay, now just choose which one you want to be your first and your second. I'm going to go ahead and make this guy my first, x1, y1. This guy my second, x2, y2. Okay, alrighty. Now I can go ahead and plug this into our formula. So we got the distance equals square root of, okay, x2, which we chose as positive 4, minus x1, positive 3, squared, plus y2, negative 5, minus my y1, 0, squared. Okay, now it's just a matter of finding these numbers. 4 minus 3?
1.
Positive 1 squared, plus negative 5 minus 0, negative 5 squared. Okay, what does 1 squared turn into? 1. Negative 5 squared, or negative 5 times negative 5? Positive 25. Okay, so what is underneath my square root? 26. We have the square root of 26. Okay, now, on your assignment and on your test, it's going to say something like, give me the exact answer. That's what it means by exact. Okay, the square root of 26 is your exact answer. If it ever says something like, give me the approximate answer and then round it to 1 decimal place, it means it wants you to enter this into your calculator. Square root of 26. Okay, help me round that to 1 decimal place. What would that be? 5.0 or 5.1? 5.1, right? The 9 behind the 0 is going to bump it up. So that would be my approximate answer, 5.1. Love it. Okay, let's do that again. Might not do all of these if you guys are feeling good, but let's go ahead and practice some more. Number 2, somebody give me one or both of these coordinate points that we're working with, Leo.
Negative 2, negative 1.
Love it. Negative 2, negative 1. And what about this guy over here?
Positive 3, negative 4.
Beautiful. Positive 3, negative 4. Love it. Okay, again, I'm just going to make this guy my first one, x1, y1. This guy my second one, x2, y2. Okay, plug it in. Distance equals the square root of x2, positive 3, minus x1. What happens when I subtract a negative, though? Turns into a positive. So 3 plus 2 squared, plus y2, negative 4. Again, subtracting a negative, which means we are adding, plus 1 squared. Subtract a negative really means you are adding. Ooh. 3 plus 2? 5 squared. Negative 4 plus 1? Negative 3 squared. Okay, what is 5 squared? Or 5 times 5? 25. plus negative 3 squared.
Negative 9.
Negative 9.
Positive 9.
Positive 9, there we go. Negative times a negative gives me positive. 25 plus 9. 34. We have the square root of 34, which is technically our exact answer, the square root of 34. Let's go ahead and find the approximate answer. That little squiggly, what'd you get, Nora?
0.8.
Let's see. You're absolutely correct. Okay, that 3 behind the 8 is not going to bump it up. So it is going to stay 5.8. Okay, show me a fist of 5 on distance formula. 5, oh yeah, I'm feeling confident with this on the test. 4, feeling pretty good. 3, I could use a little bit more practice. How are you guys feeling? This will determine if I need to do another example, so be honest. Let's do one more distance formula. Okay, we'll go faster this time. Somebody give me one or both of these coordinate points we're working with. For number 3. Nora?
1 and negative 2.
Got it. Positive 1, negative 2.
And then negative 3 and negative 5.
You got it. Beautiful, beautiful. Okay, your assignment might be really nice. You might not have to identify the coordinate points, but always good practice. So this one, I'll make my x1, y1. This one, my x2, y2. Okay, let's plug it in. Distance equals the square root of x2, negative 3, minus x1, positive 1, plus y2, negative 5, minus y1, which is a negative number, which means we are going to end up adding it. Subtracting a negative means we are adding. Negative 3 minus 1.
Negative 2.
Negative 4 squared. Negative 5 plus 2. Negative 3 squared. Okay, what is negative 4 times negative 4?
16.
Positive 16. Negative 3 times negative 3?
Positive 9.
Positive 9. 16 plus 9?
25.
25. Ooh. What do we love about 25? What is it, Kane?
You can break it down.
It's just 5, right? The square root of 25 is a perfect square number, which means your exact answer is 5. Square root of 25 is 5. There's no rounding we have to do to that one. Beautiful, nice, pretty 5. Okay, awesome. Let's go ahead and skip number 4. Let's talk about our midpoint formula now. Okay, so for numbers 5 through 8, it's asking us to find the midpoint of each line segment, meaning the coordinate point that is directly in between them. Okay, so we want to write down our midpoint formula again. So midpoint is going to be parentheses, my second x plus my first x divided by 2, and my second y plus my first y divided by 2. And that's going to give me my new coordinate point. Add your x's, divide by 2, add your y's, divide by 2. Okay, easy peasy. Well, let's go ahead and practice this guy. Number 5, somebody give me one or both of these coordinate points. What are we working with here?
4 and 1. Negative 1.
Good job. Positive 4, negative 1 for that guy. What about this one?
5 and negative 4.
Nice. Positive 5, negative 4 for that coordinate point. Okay, again, I want to label my first one and my second one. So we're going to have to plug those in. Okay, plug it into our formula. It just looks a little different this time. So x2, 5, plus x1, 4. We'll then divide that by 2. Then my y's, negative 4 for y2. Okay, and here's where you're like, am I adding? Am I subtracting? What's going on here? Okay, y2 plus y1. When you're adding a negative, okay, that just turns into subtraction. So negative 4 minus 1 divided by 2 because of that negative. Okay, so now we just go ahead and crunch our numbers. What is 5 plus 4 going to turn into on top?
9.
9 divided by 2. Negative 4 minus 1?
Negative 5.
Negative 5 divided by 2. Okay, these are not going to be nice, pretty numbers. That's okay. They'll be decimals. Totally fine. If you did 9 divided by 2, what would that give you as a decimal? 9 divided by 2. What are we going to get there? 4.5 for my x, and that's totally fine to get that. What about negative 5 divided by 2? It's going to be a negative 5 divided by 2.
Negative 2.
Negative 2.5.
5.
There we go. Okay, totally fine that we get decimals for our answer. That is the coordinate point that is directly in between those two coordinate points. Okay, awesome job, you guys. Number 6, what two coordinate points am I working with here? Carl, what you got?
Positive 1 and positive 5.
Beautiful. Positive 1, positive 5. What about this guy down here? Carl?
Negative 4.0.
Ooh, very close. 0 for my x, and then down to negative 4 for my y. Beautiful. Okay, x1, y1, x2, y2. Okay, plug it in. Add your x's divided by 2. Add your y's divided by 2. So x2, 0, plus x1, 1, divided by 2. Now my y's, y2, negative 4, plus y1, positive 5, divided by 2. 0 plus 1? 1. And negative 4 plus 5? Also 1. Okay, now, this guy, that's a simplified fraction. He's reduced. You can't reduce him anymore. So that would be a totally acceptable answer, 1/2, comma 1/2. But if you wanted to do it as decimals, what is 1/2 as a decimal? 0.5. So you could also write it as 0.5, comma 0.5. Both of those guys are totally acceptable. How are we feeling with midpoint formula? Add the x's, divide by 2. Add the y's, divide by 2. Want to see it from everybody. How you feeling? Fist to 5. All right, let's do one more then. One more. Ooh, let's look at number 8. I want to find the midpoint between this little guy. Okay? What are my coordinate points here? Nora?
1 and negative 1.
1, comma, negative 1. What?
0 and negative 2.
And 0, negative 2. Okay. Alrighty. x1, y1, x2, y2. Okay, let's plug it in. See what our midpoint, what is the point that's directly between them? x2, 0. Plus x1, positive 1, divided by 2. y2, negative 2. And when I'm adding a negative, okay, you're just subtracting. So negative 2 minus 1 divided by 2. Okay, adding a negative means you're subtracting, right? We're good there. 0 plus 1 on top?
1.
Just 1 divided by 2. Negative 2 minus 1?
Negative 3.
Negative 3 divided by 2. Now, are these guys reduced fractions? Yeah, they are. We can't divide anything to make them any smaller, so that's a perfectly acceptable answer. Or you could write them as decimals. 1/2 as a decimal is what? 0.5. Negative 3 divided by 2 is a decimal? Ooh, negative 1.5. And that's totally fine too. Either one of those guys, perfectly fine. Beautiful. Okay, let's turn your paper over. Still a couple more concepts we got to talk about. Okay, so let's look at numbers 9 and 10. Okay, it's asking us to find the missing side. Whoops, and I totally forgot to identify which missing side on 10 is. Boom, put your X right there. Whoopsie. Okay, so we are asked to find the missing side of a triangle. We know how to find the missing side of a right triangle, if it's a perfect right triangle. How do we find a missing side of a right triangle? What theorem do we use? Pythagorean theorem, right? So we might use Pythagorean theorem if it's a right triangle. A squared plus b squared equals c squared. Okay, that could help us. But it has to be a right triangle in order to use Pythagorean theorem. Look at number 9. Is number 9 a right triangle?
No.
No, it's not. There's no perfect right angle here. Okay, it's identifying that the missing side we want to find is this guy. Well, if we can't use Pythagorean theorem, what can we use? What formula do you think? Were we just using that we could find the hint distance between those 2 points? Midpoint or distance formula is going to help us here. Is the midpoint going to help me find that missing side, or is the distance going to help me? Distance, thank you. Okay, we can just use the distance. Okay, we don't really care about these 2 sides of these triangles. So all we need to do is identify these 2 coordinate points, just like we were doing, and then find the distance. Boom, there's our missing side of a right triangle. What are these 2 coordinate points? Carl?
2.3.
We got 3 up to 2, beautiful, 3 comma 2. And then what about that guy? Leo, what you got?
4, -3.
You got it. Okay. So here's an option to find the missing side of a right triangle. We just use our distance formula: x1, y1, x2, y2. Okay. Let's plug it in, see what we get. What is the missing side of this triangle? So we got the distance equals x2, 4, minus x1, 3 squared, plus y2, -3, minus y1, 2 squared. 4 minus 3 in my first parentheses? 1. 1 squared. -3 minus 2? -5 squared. Okay, 1 squared, or 1 times 1? 1. -5 times -5? 25. Okay, so what is the missing side of this right triangle, or the distance between the 2 points? The square root of 26, which we even found on the front of our paper approximated to be 5.1. That would be the missing side of this triangle. Okay, beautiful. Number 10. Is this a right triangle, you guys?
Yes.
Yes, it is. So what can we use instead of the distance formula? Pythagorean theorem. Okay, so we need to know what my A and B sides are, though. Well, you can just count up the spaces. What are my A and B sides? Who's got this side? How many spaces? What do we got? 6. And what about my other side? 6 as well. Okay, so now we have my 2 legs of my right triangle. I can plug it into my Pythagorean theorem, because this is A, this is B, my X is C, which means I can go ahead and plug it in. So A squared, 6 squared, plus B squared, another 6 squared, equals my C, X squared. Okay, from here you guys know to just get rid of those squareds where you can. What is 6 squared, or 6 times 6? 36 plus another 36 equals x squared. Now, do I need to move those 36s or combine those 36s? Combine. They're both on that side. So go ahead and combine them. 36 plus 36 is going to give us what? 72. Okay. What is my last step? How do I find the missing side of this right triangle? Square root it. Opposite of square, square root. Okay, can put that in our calculator. We got square root of 72. Beautiful. Okay, if I want it rounded to 1 decimal place, the 8 behind the 4 is going to bump it up. So the missing side of this right triangle is 8.5. Beautiful. Okay, numbers 11 and 12. Okay, it's asking us to find the area of the triangles. Okay, this is just like number 2 on our starter. The area formula, area of a triangle, remember it's 1/2 times base times height. Looking at number 11, can we find, just like on our starter, the base and the height? Just by looking at our triangle. Yeah, we can, right? To find the base, I want it to be completely flat, where I can just count the spaces. I can just move my triangle like that. What would my base then be? 3. What would my height be? How tall is this? How many spaces up? 1, 2, 3 as well. Okay, so now I have everything I need to find the area of this triangle. I just had to kind of maneuver it and look and find. Okay, so I can plug in my area formula. Area equals 1/2 times my base, 3, times my height, also 3. Okay, and you can just punch this right into your calculator. Remember that 1/2 is also 0.5. So 0.5 times 3 times 3. Boom, boom. 0.5 times 3 times 3. Or think, what is half of 9? It is 4.5. Okay, whenever we are talking about area, it's units what?
Squared.
Squared, always. Even though it doesn't tell us what the units are, we must identify that it is units squared. Alrighty. Okay, I want to skip number 12, okay, because we need to talk about one more thing that I actually forgot to put on here, okay, and that is classifying a right triangle using Pythagorean theorem. So we'll just go ahead and call this question 13. Okay, let's say I am giving you this right triangle. I'm just going to make this up on the top of my head. Let's do 7, 11, and 13. Okay, so we need to identify whether this is a right triangle, perfect right angled triangle, an acute triangle, or an obtuse triangle based on Pythagorean theorem. Okay, we're not solving for a missing side. We know all the 3 sides. It gives us those. Okay, but assuming it's a right triangle, where are my A, B, and C sides? Okay?
13 is C.
Mhm.
11 is B. 7 is A.
Love it. Love that he chose his C first. That's the most important one. Okay, so now let's just plug it into Pythagorean theorem, see if it works. Okay, so we have A squared, 7 squared, plus B squared, 11 squared, equals my C squared, 13 squared. Okay, if it works out perfectly, it's a right triangle. If not, it's either an acute or an obtuse triangle. Okay, what is 7 squared? 7 times 7?
49.
49.
I'll wait. That's time.
11 times 11?
121.
121. And 13 times 13?
169.
169. Okay. Now I just need to add these 2 numbers on this side. What is 49 plus 121? Nice. You guys are good. 170. Ooh, we are so close. But that definitely does not equal each other. 170 does not equal 169. So we need to decide whether it's an acute or an obtuse triangle. So let me ask you guys, which side was bigger? Was my A and B side bigger, or was my C side bigger?
A and B.
A and B, right? So 170 is bigger than 169. When the A and B sides are bigger, or think your C side is smaller, this would be an acute triangle. Okay, because C was smaller than my A and B. Okay, one way you could remember that, like think if A and B are bigger, you can think A acute. I don't know, some memorization trick. you want to see one more of those examples before I set you free? Or are you good with
Yeah, we're good.
classifying? You're good? Okay, sounds good to me.